Hello guys, it's me again with another train tutorial. This time we are going to create this landscape together. You can download the executable file for this train down in the video description. This train also has an Android version which runs 30 frames per second on my cell phone. This video is more about learning. I don't want to create a complete train, I just use some free asset and also I put some asset together fast to create this train. If you change the asset of this train with better one, you can achieve much more better result. So in this video we are going to see how we can create this train or landscape from zero. I'm going to explain about each part. First we are going to talk about some base concept about train. After that I will show you how you can export your train correctly from software like Word Machine to later import that in mtrain plugin. Next we are going to import our height map to our train. We create the train, we also create train shader. Then I'm going to talk about how the grass system works in mtrain plugin. After that I will show you how you can write some script to automatically place grass on train. Then we are going to add some trees and I will show you how you can add collision to these trees. After that I will add some small and big rock, and at the end I'm going to add some fog with grass system. You can also download the Godot project for this in my Patreon. And really thanks to all of my Patreon to give me support. One thing that I want to tell you before going any further is that there are thousands ways of creating train. In this video we are going to discuss about one of them. This method is not splat mapping or index mapping. This is another method which I did not see people talk about that much. And basically I come up with this method by myself. So let me first give you an idea how this is going to work. To better understand this concept, first let me explain this. Everybody knows that we can decompose any image to its red, green and blue component. But this is not the only way to decompose an image. We can also decompose any image to three other components which are luminance, blue chrominance and red chrominance. I know you are asking why this is useful. Just wait, I will explain everything. The advantage to decomposing an image this way is that we are separating luminance from colors. Luminance show how bright each pixel is, and color show what color each pixel has. Here luminance is much more important than other two components. The reason is that human eyes are much more sensitive to brightness changes than color changes. This means I can downsample the color component and I put back everything back together and you will not notice anything. This method is used to compress images in JPEG compression algorithm. Now you might ask what all of this have to do with train. Usually train is big and we cannot create an image which covers the entire train. And also if we create an image which covers the entire train, no matter how big is that texture, it will look pixelated. But what if I create a low resolution only color image for entire train and then add another high resolution image for its luminance value? And then I mix these together. So this method has some advantage which I will tell you here. First of all, by this way your train will be so flexible and you can easily create different biome only by changing color map. Also this method has much more less texture tiling problem. It also has a good performance. Just one thing. This method will give you a special art style which you may like or not like. And one last thing is that you don't have to use only this method, you can use this method mixed with other methods. So in this video I'm going to use this method, but in this video you will also understand the workflow of mtrain plugin. So even if you don't use this method, this video will be helpful to you. So here we need two things to create our train. First we need a height map and second we need a color map. I am going to generate a height map and color map with Word Machine. But if you don't use Word Machine, don't worry. You can use anything else or even you can sculpt the train inside mtrain plugin. Another important thing is that it is better to generate this color map by yourself with GDScript code. That way you have more control over this. One way to do that is just by putting different color on different slope. There are also more advanced ways like detecting where water flow is and this kind of stuff. It is even possible to generate this color map inside your shader code at runtime. So before creating train, let's discuss how to plan everything. There are a lot of parameters which you need to set depend on the type of the train which you are creating. First, you should determine your horizontal scale. Horizontal scale basically means how many height map pixel per each meter. M-Train support different horizontal scale. I usually use 1 pixel for each meter, and that is also the default value. For example, if you are making a game in which the player is far from the train, like a flight simulator, you can also use a bigger horizontal scale like 8, which means each 8 meter has one height map pixel. Also in this video I'm going to set my horizontal scale to be one height map pixel for each meter. The next thing which you should determine is the train grid size. Basically we break the train into the grid, which causes some train chunk to be called and not shown. The default value for grid unit size is 32 meter. I will leave that to the default size, but you feel free to change that and see which size is better for your performance. Now, beside dividing the train to a small chunk of 32 meter, we also divide our train to different region. You know, as the train become bigger, the height map resolution also become bigger with that. The maximum height map resolution which we can have is 16K. This limitation has nothing to do with Godot engine. This is a hardware limitation. Also, this limitation is much more in mobile devices. In some mobile devices, the maximum texture size is 2K and in some is 4K. So what we are doing here is to divide our huge height map into smaller pieces. Doing this has other benefit too. For example, we can downsample the height map resolution which is far from the camera. And in M-Train, a special algorithm has been implemented which does this kind of stuff. So considering this, I usually put my region size to be 1024 by 1024 pixel. You can also try the region size of 512 or 2024. That depends on your train and how much of your train is loaded at each time. For this demo, I used 1024 pixel region size, and as I used 1 pixel for 1 meter, you do the math. This means each region is 1024 meter by 1024 meter. Here we should do one more math and we are done. Do you remember I put all of my train on a grid, which each grid unit was 32 meter? We should calculate how many grid unit will take our region. So if I divide my grid region size in meter to grid unit, I have 32 and that means my region size in grid unit is 32. Next, we should determine how big is our train. In this video, I'm going to create a train with a size of 8192 meter by 8192 meter. And as we use 1 pixel for 1 meter, the train size in pixel will be 8192 pixel. One thing you should pay attention to is that your train size must be divisible by region size. So in this case, we have 8 region in X direction and 8 region in Z direction. So here we should understand what are these terms. Horizontal scale, which determine how many height map pixels we have for each meter. Grid unit size, which determine what is the smallest train chunk size. Region size, which determine how we divide our train. And finally, the train size, which determine the entire train size. Now we have also other settings for train which are not important as this. These are important and changing some of these could be difficult down the road. You will see in a moment how we are going to use this data to generate our train in Word Machine. Well, now let us see how we can create our train in Word Machine. Here I am not going to explain how the Word Machine works, but I will only explain how you can export your train correctly here. So later you can import that in M-Train plugin. With a free version of the Word Machine, you can export up to 1K resolution height map. And basically there are two ways to export your train with a Word Machine. You can export that as one file, the entire train, or you can export that as tiled. If you export that as tiled, your tile size must match your region size. You will see that in a moment. So here in Word Machine, first I start from a Perlin noise, and then I added other stuff like erosion. Also in a Word Machine, there is a node which is called quick texture. I used that to create the color map. Here we need to save two output. The first one is height map, so I select the output tab and I create a height map output node. I also need an output for the color map. For that I have one bitmap output node. Now I just connect the final color map texture to bitmap output. I also set the output file path and I save that as 8-bit PNG. Next, I set the final height map to its corresponding output node, and raw 16-bit is a good format, so I choose that. So this is the important part, which you should put the correct setting for your train. Here I select the train resolution setting, and here you can see the train width and height is almost correct. It is 8 km by 8 km. This is exactly what we have calculated. First, I uncheck the +1 in resolution setting. As the newer version of the M train, we are not saving the train as the power of 2 plus 1, so this is not necessary anymore. Next, I increase the resolution to be 8K resolution. Now we have a correct horizontal scale, 1 pixel for 1 meter. I click on the build and this can take a while, so I fast forward this section. It took me almost 7 minutes to build this. After this, you should click on both output node and write them on disk. There is one more important piece of information which you need, and that is the maximum height and the minimum height. For that, click on the resolution setting in the general setup tab. You can see the base elevation is 0 and the max elevation is around 2600. You will need these numbers later for importing this height map. Now let's see how we can import the tiled version of my train. Click on the tiled build option. You remember that we calculated that our region should be 1024 pixel by 1024 pixel. Also, the entire train size is 8K. And we have 8 tiles in each direction. Here the same rule will apply. Change your tile resolution to 1024 pixel and change the tile per side to be 8 by 8. You can see the word machine has already calculated the final train size for us. Also, you should make sure that the size of the train is still 8 km by 8 km. After changing the tile setting, just click on the tile build. It will take a while to build the train, so see you when it's finished. Okay, now I have my height map and color map. Just download the M-Train plugin, activate that as a plugin, and also restart Godot after that, so you can make sure everything works correctly. This is my scene. I just added the M-Train plugin node here. Now I need to adjust some setting based on what I have created in the word machine. Otherwise, it will not work. First important thing is to make sure you have the same horizontal scale. Here the mean horizontal scale should be the same as the horizontal scale value which we determined before. There is another thing which is called max horizontal scale. Basically 1 pixel for each meter is for train closer to the camera. As we go further away from the camera, train will automatically increase the horizontal scale, or in another word, it will increase the train LOD. And here maximum horizontal scale means the maximum horizontal scale which can train have. By default, this value is 32 meter, which means the highest LOD size is like this. Personally, for this demo, 32 meter is too much, so I will reduce this to 16 meter, at least for now. Maybe later I will change it. So we have better train further away. So now each LOD is like this. We have another setting which is called mean size. This is basically determine the grid unit or the smallest train chunk. So what max size means? Basically, as we put train inside a grid, it is not efficient for creating each grid unit a train chunk. What we do here is to merge train chunk further away from the camera, and this number means what is the maximum size of the train chunk. Next, we have the max range. Just put this to a big number and don't worry about that. This is not important. And next one is region size. This region size is in grid unit. Currently, our grid unit is 32 meter. So if you do a simple math, this means our region size in meter is 512, which also means it is 512 pixel. If you click on the info button and select the region tab, you can see this information. Just one thing is that the region pixel has one common pixel at edges, which will made automatically at load time. You should not worry about that. This is why it is written that the region size is 513 pixel. So basically here, to correct the region size, I will put that to 32, which means 1024 meter or 1024 pixel. So let's set our train size. Our train size was 8,912 square meter. If we divide that to the grid unit, we have 256 units. Next, we have physics update limit. Basically, for each region, we create a collision shape for physics, and these show up to how many regions around the player we should create collision shape. 1 is completely okay for this. Next, we have some more settings which are not so important. You can read about them in the wiki page. And we arrive at the one more important setting which is called region limit. This basically means up to how many regions around the player should be loaded at each time. The default value is 2, but I recommend to increase that during develop time if you can. Also, one other important thing is that the region loaded around the player must always be bigger than the physics limit. Otherwise, that can create some edge problem. For now, I leave this to be 2. I will change that later. Next, we should specify a data directory for our train. For now, I don't need a layer data directory, and later I will add this. So this was about the train setting. Now it is time to import our train. There are two ways to import your train. First one, to import your train as a unique file, and second one is that to import that as a tiled version. In this video, I will show both ways. First, I will show you how you can import the non-tiled version of mtrain. Click on the project, tools, mtrain, import export. In this panel, select the height map file which you have created. So this is the 8K height map which we had. Here mtrain importer does not know how to divide this height map, so we should specify the region size. So I put the region size in pixel here. Next, check is height map. You can see some setting changed when you click on that. And the uniform name automatically changed to height map. Now here we should set our min and max height. If you remember from the word machine, max height was 2600 meter. So in this case, I like that my train also go below 0. So I put my mean height to minus 600 and the max height to be 2000 meter. Here also I use the new compression algorithm for train and I change the accuracy to be 5 cm. This basically brings down the size of the height map a little. Then just select the data directory for your train. Now just click on import. Depend on size of your train, this can take a while. Okay, we imported our train. Now if I look inside the train data directory, you can see we imported each region separately as a different Godot resource. And inside each resource, there is a packed byte array, which is the data for your height map. Just don't change anything in this packed byte array. Now let's import our color map which we created. Same as before, open the import tab, choose your color image and set your region size in pixel. Now here you should choose a name for your color image. We use this name later in shader code. Here I choose RGB8 for color format and for compression I choose QOI compression. Click on import and after importing, if you look at the train data directory, you can see in each Godot resource, we have one packed byte array for height map and one for color map. So now let's see how we can import the tiled version of our train. Tiled version is almost the same. You can see in the import tab, as I select the tiled train file, it automatically detects that. And this time, this will not ask us the region size. This is because the tiled size is the same as the region size. And this was about how you can import your train. Now as I check create train, this will create train for me. This also can take a while depending on how many regions you want to load. So this is just a piece of my train. You know, as my region limit is 2 right now, it's only load 2 regions around the camera. So to load more region around the camera, I just increase the region limit around the player. To get the train updated, I need to move the camera because train only will update if you move the camera. And after a while, other region will also load it. Now to see train far away, in view setting, I increase the far plane distance to be 8000. Another thing that you can see here, that my train start at origin and continue in positive X and Z direction. To put that on center, in the offset setting of my train, I just set the offset to my train. So you can also change the LOD setting, so train far away also will look better. But please note, this can affect your performance. Also, after putting texture and adding fog on the train, it will look better. To change the LOD setting, just open the LOD distance panel. Here, LOD 0 is defined to be 3. This means up to 3 grid unit, LOD 0 is active, which means 3 times 32 meter, which is 96 meter. After this distance, we have LOD 1, and LOD 1 will be active up to 6 grid unit. For now, I just increase the quality of the train, but you should keep this number as low as possible. For this change to get affected, you should restart the train. One other thing is that when you load an empty train like this, you cannot understand the dimension of your train. You can activate the human button and a human mesh will appear on train so you can understand its dimension better. So now let's create the first shader for our train. First destroy the train and assign a train material to it. Train material is a special class which is built to only handle train. Basically each region in our train has a different material. Train material is a way to manage all of that. After that, create a shader material for that. You can see we have a default shader code here, and also height map automatically is added here. So now we need to add the color map for train which the word machine created for us. To do that, you need to add a sampler 2D with the same name which we imported our color map, just only add mtrain prefix to that. You need to do this step before train is created. So as train will load it, the color map will be loaded properly. This is needed only for the texture with train prefix. Now I want to put this color map texture on my train. For that I use region UV. Basically region UV is 0 at top left corner of each region and it is 1 at bottom left corner of each region. So let's use region UV to read from our color map and assign that to albedo. Now our train has some color, but if you look at that closely, it will look pixelated. So we need to add more detail to this. As I explained before, we have the color of the train and we need to only add some brightness variation. So we need only a black and white image for color. First, we need to choose a good texture. Here I am in Ambient CG website. So basically I should choose a texture which contains only one substance and does not have too much color variation. For example, this one is good. I choose two texture for my train and one texture for rock. In total, I have 3 texture. So first let's create a gray texture for our brightness. I open this with GIMP. You can already see we don't have too much color variation here. So let's remove color from this image. To do that, in image, I change this to grayscale image. This image still is not good for using shader. To tell you why, let me show you the image curve. So this is my image curve. This point is the darkest and this point is the brightest pixel in my image. So to fix this, first I make this a little bit darker to put that on the middle. Then I increase its contrast a little bit. Don't increase that too much. We don't want a completely white or completely black pixels. Next, we need to pack our image. Basically, I put all of my texture into one texture. So here our normal map has 3 components, red, green and blue. For normal map, I only need 2 of its components. I can calculate the third component based off 2 other components. So here I remove the blue value of the normal map and I put the grayscale color value there. Then I'm going to add my roughness to the next channel. Open normal map in GIMP, go to color, component and decompose. Remove the blue channel, then add the grayscale image which we created. Next, add roughness, then go to color, component, compose and select RGBA and click OK. And one important thing is that when you save that as PNG, remember to activate save color value from transparent pixel. Now I have 3 textures, 2 for ground and 1 for rock. One important thing is that as we packed our texture, compressing them will not give a good result. I put the VRAM uncompressed for all of this texture. Now let me apply only one of these textures so you know how this works. First, I declare a sampler to the uniform for the first ground texture and I assign my texture to that. Next, I read from that texture and I read from that texture based on the word position in X and Z plane. You can see we need to unpack this texture. Also, you can change the scale of texture up here. Basically, by multiplying or dividing the word position, as we read from the texture based on word position, that will change the scale of our texture. So let's unpack this texture. As you know, the color grayscale or the brightness value is in the blue channel of our texture. I just multiply that by our color map. And you can see we have much better train. So let's set the normal map. I put the X and the Y value of the normal map to red and green value of our texture. You can also calculate the exact value of the Z component of the normal map, but approximating that to 1 for things like ground is okay. And finally, I set my roughness to the alpha channel. You can see my roughness is too low. I just made that to power of 0.5 for now, but it is much better to correct this roughness value in original texture. So now let's add other texture too. First, I declare two other uniform for my other textures, but the question is how should I mix these three textures? In this video, I'm going to use a sloped base mixing. First, let me explain how that works. Basically, based on the slope of the train, I'm going to create a black and white mask. As an example, you can see here in the steep train section, the mask color is white, and in other part, the mask color is black. Here we have train normals. Where train is completely flat, the y component is 1 and other two components of the train normal are 0. But where the train is not flat, the other two components are non-zero and y component is less than 1. So here I'm going to add the absolute value of x and z component, and where these absolute values are bigger, that shows us we have a steeper train. Now I am going to define two float varying. I define my variable as varying because I'm going to calculate that in vertex function and then I pass that to the fragment function. And this way my shader code is more efficient. Now in the vertex function, I'm going to add those two components together. Now define my first mask like this. Here I found this number just by try and error. And another thing is that here I used a step function which gives me the value of 1 for all n xz value bigger than 0.3, and it will give me 0 for all values n xz less than 0.3. And maybe you ask, does that step function create a hard edge? Basically here we calculate this mask in vertex function, and as we pass that to the fragment function, it will interpolate it between each vertices automatically, so it will not give us a hard edge. I do the same thing for the rock mask. Well, now let me show you the result. I put the mask in albedo, and this is the ground mask and this is the rock mask. You can see by changing the value of the ground mask, my mask value will change. This is really similar to splat mapping, but we just create the splat map in shader code. Make sure to watch my video about the splat map. I will put the video link in the description. So now let's mix this texture based on our mask. Now here there is one problem. You can see the rock texture is stretched in some places, and that is because we sample from the rock texture in XZ plane. You can fix this by using triplanar method, but I'm not going to explain about triplanar method here, maybe in another video. Now you can see our texture is tiled a little bit. So here I'm going to use distance base mixing to fix the tiling problem. I already explained about this method in another video, which I put the link of that video in the video description. And here I just fast forward everything. The only difference between this and other video is that I'm going to use only two distance level. If you don't understand this, make sure to watch other video. So let's do that. Up to this point, we have a good train. But if you look at the train closely, it is pixelated. I'm going to fix that by adding a detail texture. This is my detail texture. This basically is going to add a grainy effect if you look at the train closely. Red and green channel of this texture contain X and Y component of the normal map, and the blue channel contain a brightness change for train. First, I declare a texture uniform for my detail texture, and as this texture matter only from clothes, I sample from that with regular texture function, not distance texture. Now I'm going to mix the detailed normal map to my normal map. and I'm going to use a simple mixing method. Basically, normal maps are vectors, and there are different ways to mix them. I made a video about mixing normal map. I recommend to watch that if you don't understand this. I put the link of the video in the video description. And then I'm going to multiply my brightness to the detail brightness. Well, we added a detail texture here. This is going to add more detail when you look at the train closely. It is possible due to the YouTube compression, you are not able to see this good. So up to this point, we have a good train. But our train looks some kind of empty. I know later we are going to add grass and other stuff, but even now as we use a color map, the train looks unnatural. Here I have this scatter leaves texture and this scatter rocks texture, which I want to add them on top of my train. Unfortunately, I could not find a good and free texture for this purpose. I just used these two textures only to show you how this works, but you need to work much more on this section. First, I import my texture into shader. Then I free it from that, and then I mix that with my albedo texture based on the leaves alpha channel. Now I don't want my texture to cover the entire train, so I use a noise mask texture to distribute my leaves on train. You can also make a new train image and paint leaves on train. So this is my noise. I control the noise black and white area with a gradient. And now if I multiply the leaves alpha channel to this noise value, leaves will appear only where noise is white. You know what? Let me remove the gradient and use a smooth step function to control the black and white part. This smooth step function does almost the same thing which the gradient did. There is one more problem. You can see some of my leaves appear on rocks. We can solve this problem easily. So we have a rock mask, which where the rock exists, it is white, and in other part, it is black. I just invert that rock mask and then multiply that to my leaves alpha channel. Another problem is that the normal map on leaves are the same normal map which belong to the train. Here I don't have a normal map for leaves, so I just use an up vector normal map on leaves. And this at least can separate a little our leaves from the train. But here the best thing is that to use a normal map for leaves. Now let's add our rock texture. First I import the rock albedo and normal map texture. Then same as before, I mix that with albedo. And then I'm going to add the rock's normal map and mix that with the base normal map based on the rock alpha. Also I'm going to use noise value to distribute my rocks on train. But this time I'm going to read from different part of the noise value so rock will not appear exactly at the same position of leaves. At the end, I'm going to adjust the scale of the leaves and rocks. And finally, this is our train. So up to this point, we work only on train. Now it is time to work on grass. I already made a video about grass and I explained how it's work. Here also I explain about the grass system in mtrain plugin a little bit. Grass in mtrain is divided into a grid. You can see I put one grass in each grid cell. After that, I randomize each grass in its cells. Grass in mtrain follow exactly the train LOD. This means where the train LOD is 0, the grass LOD also is 0. And where the train LOD is 1, the grass LOD is also 1. And it does that in two ways. By modifying the grass mesh and by modifying the grid size. The most important setting for the grass is called density. Density determines how big each cell of the grid. For example, if the density is 2 meter, this means each grass cell is 2 meter big in each direction. So here I prepare these three mesh for our grass. This is the LOD0. For LOD1, I use the same mesh, I just remove some grass in the middle. And for the LOD2 and the bigger LODs, I use a billboard texture which rotates toward the camera. For this, I'm not using Godot billboard. I wrote this billboard by myself in shader and I put the video link which explains this. Well, now let's build our grass. So first you need to destroy the train and then add a mgrass node as a child of the train. After that, create a grass data for that. I choose the grass density to be 2. Then save your data with .res extension. You need to do all of this step before creating train, and this is really important. Now after you create your train, the grass data will be initialized automatically, and you cannot change the density of the grass anymore. If you want to change the density of the grass, you should remove the grass data and recreate another grass data. Now I just add those grass mesh which I created to its corresponding LOD. Just one thing, I use the same LOD for LOD 2 and 3. There is one important thing here which you should know. Here any grass LOD mesh which is not assigned is not going to be shown. For example, grass with LOD 4 are really far away and I don't want them. So I simply don't assign any mesh to them. As I apply the grass material on the mesh, I don't need to change anything in the grass material. Now as I select my grass, I activate the paint mode and I start painting. For now I paint on a big area, so I want to see how my grass look like from the close and the far. So what we need to do now is to randomize our grass. In LOD setting, just create a new LOD setting resource. You can see my grass already randomized itself. And please pay attention, what I am changing right now will affect only the grass with LOD 0 or the grass which are closest to the camera. So here let's solve the first problem. You can see my grass is a little bit above the ground. I correct this by adding a negative value to offset in Y direction. Next, I will increase the grass number in each cell. Here also there are other settings for randomizing our grass. For example, here rand position int is 1 in X and Z direction. And this LOD setting is going to randomize each grass from the start of the cell to the end of the cell in X and Z direction. I explain about these things in another video dedicated to grass. I really recommend to watch that. Next, I'm going to create some uniform scaling randomization and make a little bit grass smaller. Then I randomize the rotation of the grass around the y-axis from 0 to 360 degrees. Also, I rotate grass around other axes a little bit. Now I just save this setting somewhere. Maybe increase the number of the grass a little bit. Now I just copy my LOD setting to LOD1 and make sure to make that unique. Now let's adjust the LOD setting for grass in LOD1. Basically, I don't want that my grass grid size to change as I move from LOD 0 to LOD 1. So here I set force LOD count to be 0. This means I want a grid size same as LOD 0. And now the point here is this. If you keep the same setting and the same seed number, this will generate the same random number like before. And we just change the mesh of LOD1, not the number of them. In LOD2, I want to use the same grass grid like LOD0, but I just remove the rotation around y-axis. This is because in this LOD, I use a billboard texture which rotates toward the camera by itself. Now let's adjust LOD3. As these grasses are really far away, I use the grid size to be LOD1. Also here I change the size of the grass to match other grass. Here there is another problem. You can see the grass which are further away are disappearing. This is because I am using an alpha scissor for grass transparency. To fix this problem, I just reduce the alpha scissor threshold value for grass further away and I adjust the value here. Now I just play more with the LOD setting numbers to get a better result. And I just fast forward this part. Okay, now we have our grass. Next thing that I want to do is to make a way to place grass automatically on terrain. What I want to do here is this. I want that grass will appear only where terrain is mostly flat. I also want to add some randomization to grass. To do that, I add a script to grass node. I remove these as we don't need them. Now here we want to run the grass generation algorithm. And for that, I just connect the grass is ready signal to that function. So this function will be called after your grass is ready. You should make sure of two more things. First, make sure you saved your grass data. Otherwise, this will not work. Next, you should make sure all regions are loaded. So I change my region limit to some big number. If some part of the train is not loaded, this will not work. So I increase this number to a big number. Now we are ready to write our script for generating grass. Remember that I said each grass is in grid. Here we want to turn on or turn off each cell based on some information. So first let's create a loop which loops through all the grass grid. Here get width and get height will give us the dimension of the grass grid. Also X and Y is the position of each grass cell. You know our train also has some kind of grid. Basically each pixel of our height map can be a grid cell. So here we have two grids, one for grass and one for terrain. You can imagine that our grass is like an image And also our train is like another image. And these two images have different resolution, but we put them on top of each other in the same space. Now if I have a pixel position in my grass image, how can I map that to the train pixel? Inside the grass class, there is a function which map a pixel position from grass space into train space. This function is grass pixel to grid pixel, and this will give you the pixel position on train. Now you can access anything you want on train with this pixel position. First I grab my train node, and now I just grab my train normals. Basically where train is completely flat, train normal is 1 in y direction and 0 in x and z direction. So that tells us where train is mostly flat, the y component of the train normal is close to 1. Now I create a boolean variable which tells us if in this x and y position we have the grass or not. And then I assign that boolean variable to this. Here when y component of the train normal is bigger than 0.96, has grass is true and otherwise it is false. After that I just set the grass at that position to has grass value. Now this will work, but I also want to randomize this with noise. I am going to use fast noise function which Godot provided. First let me show you what visually will happen. This is a simplex noise image. Here I am going to set a threshold for true and false. This means for each pixel, if the value of the pixel is above some threshold, I am going to consider that as true, otherwise false. But you can see this noise has a clear edge between white and black. And if I assign this to my grass, it will look a little bit unnatural. So I just increase the fractal gain and that helped to fade the grass edge. Okay, let's implement that. First I create a fast noise object and then I increase its fractal gain. Also I change its frequency a bit. You can play more with this noise setting, maybe you will get a better result. Now I'm going to grab the noise value at x and y position and then I add the effect of my noise in the grass generation like this. Now there are two more things that we should do. First we should save our grass and then we should call update dirty chunk. This function will help to visualize our grass which is generated after running our game. That is not bad. You can play more with the grass generation setting to achieve a different result. Some train generation software like Word Machine has some algorithm which approximate the water flow position on train. And if you use that map, this will look much more natural. So it is time to add some trees. Here for tree, I have 3 level of detail. This is the tree with LOD0. And one important thing about adding meshes which is going to scale a lot in your scene, you should create an adaptive shader for that, which when it scales, its texture scale will also change with that. You can see when I change the size of the tree, it will resize its texture automatically. And this is the tree with LOD1. You can see the branches which were inside the leaves have been completely removed. And this is the tree far away, which is just a billboard texture. Like before, I created a grass node as a child of the train. This time I put the density to a big number like 16. Put 3 meshes in 3 places and create train. Now we can paint some tree. I add a LOD setting for tree with LOD0. Then I just scale uniformly tree, something between 1 to 10 times. Add a negative offset. Then I just copy LOD setting to LOD1 and then I just put force LOD count to be 0. So both LOD have the same cell size. Also for both LOD, the same random number will generate it. Next, I copy the same LOD to LOD2 and as I want to make small changes here, I make this LOD setting unique. Here as we use billboard texture, I just remove rotation around y-axis. Now you can see the color of the billboard texture does not match other trees. Let me try to fix that. I will fast forward this section. You know, I kind of make that better, but I think my billboard texture is not good enough. But for this demo, this is okay. Now let's add collision to tree. Collision only matter for trees with LOD0 or trees which are closest to the camera. Tree with LOD bigger than 0, they don't have any collision. So first we need to create a collision shape for our tree. Make sure that tree has a scale of 1 in all direction. I create a cylinder collision shape for my tree and then I fit that on my tree. Next, in grass, under collision, I add the collision shape which I have created. Now if I run my game, you can see the collision shape is not resized when tree get scaled. To resize that, just check active shape resize. Maybe I will keep this on by default for future version of mtrain plugin. Now if I run the game, you can see the collision shape match exactly on tree. So how does this work? Here it is important to know some rules. You know, any mesh can be scaled in X, Y, or Z direction. So in the case of the cylinder, we have two parameters. One is the height of the cylinder and one is the radius of the cylinder. Here the cylinder adjusts its height with the scale in Y direction and it also adjusts its radius with the maximum scale in X or Z direction. In case of the sphere collision shape, we have one freedom which is radius and it adjusts itself with the maximum scale in all direction. In case of the box collision shape, the dimension of the box adjusts itself with its corresponding scale direction. So here as we have a cylinder collision shape, it is important that the scale in X and Z direction are same. After this I added some rock. There are 3 levels of detail for rock. Also for rock collision shape I use a simplified convex collision. I also added some fog. This is basically the fog plane which when you get close to that, it get fade slowly. And then I add a grass node for fog. And I set fog plane mesh for LOD2 and above. After that, I also added some small rocks, I did some post processing, and I played more with grass randomization and grass LOD setting. I could reduce the LOD distance and I could remove grass with LOD3. Tell me what do you think, and if you have any question, let me know in the comment section. You can also join my Discord channel, the link is in the video description. Thanks for watching, until the next video, have a good time.